Thanks. Okay, so my name's Rosie Hamilton. I work as a software tester at a company called ScotLogic. I would like to talk to you today about, my talk is called Both Sides of the Coin. Now, have you ever noticed how software testing can be neatly divided into two separate halves? For me, it's like, it just seems too simple. It seems too simple. Everything in software testing is really hard, and it seems too simple that we can split everything neatly into two different piles. Now, I'm going to talk about some of my experiences tonight, and I hope that these experiences may feel familiar to you. For me, software testing started in 2005. I got a job as a games tester. I was working at Xbox in Slough, and my first day on the job, I came in, didn't know what to expect, didn't know what software testing was, didn't even know what I would be doing. Fortunately, I got paired up with a more experienced tester, and I was told that I would be testing a cricket game that day. Not a cricket fan, didn't really know very much about cricket, but I got matched up with somebody a bit more experienced and basically told to test the multiplayer, the co-op in this game. And what happened was, because I wasn't really engaged with the cricket theme, I got quite bored. I started messing around with the game and pressing buttons, and what happened was there was a coin toss right at the start of the multiplayer which decided who got to bat and who got to field. And I very quickly discovered that even though I was player 2, if I didn't win the coin toss, I could still move the cursor left or right over bat or field. So what would happen would be the person I was working with would say, they'd win the coin toss and they'd say, oh, I want to do batting. And they'd go to press the A button, and just as they were about to press the button, I'd nudge it to the other side so they would field instead, which they got quite annoyed about. But fortunately, they were able to recognise that that was a bug, and that was my very, very first bug, the coin in the cricket game. Regardless of whether you won or lost, you could select battlefield. So this is why I called it Both Sides of the Coin. It's sort of about coins, and it reminds me of my first bug. So I need to get some definitions down from the start, because we talk about software testing and we all seem to use different words in the different organisations that we're in. We've all got different words for different things. I know ISTQB have tried to sort of get a definition list of terms and stuff. But I just want to sort of start by introducing these two sides of the coin. And for me, they are testing and checking, okay? Now, there was a white paper written at the start of the year by James Back and Michael Bolton, two sort of big names in terms of sort of context-driven testing. And they wrote about 10,000 words between the difference of testing and checking. So I'm just going to condense 10,000 words down into a little diagram, because this is what testing and checking is for me. Now, testing is, and this is my observations and what I've seen, what I've been doing testing. Performing a new interaction, making a new observation, discovering new information, evaluating that information and drawing a conclusion. And the most important thing here on the testing side is that everything is new. It's kind of done for the first time. So I would think of an idea, I would think of an interaction, I would perform that interaction and I would make an observation, discover information, and I would use an oracle to evaluate that information. Is everyone aware of the term oracle? Is any hands up who can tell me what an oracle is? Is anyone able to tell me what an oracle is? You can tell me what an oracle is.
Source of information.
Source of information.
Or a document or
yes.
experience.
Yeah. Source of information. Now, historically, oracles are things that will tell you whether a test has passed or failed. Things like you might be looking at an old version of the software to compare it and see, did it used to do this? What's it doing now? You may have like an expert user, you may have a person you can ask, you know, is this right for the software? Also things like you may have a competitor's product, you could check the competitor's product. But all of these things, the competitor's product, the person, the old version of the software, they're all oracles. They let you know whether a test has passed or failed. But you see, I'm in two minds. I don't think an oracle tells you whether it's a pass or a fail. I think an oracle tells you whether there's a problem or not. because pass-fail is very, very black and white. So this side with the testing, this is done by sentient humans. This is done by people that are able to think critically about what they're going to interact with and work out and draw conclusions at the end. Now, testing unlocks checking, because to me, what a check is a repetition of an earlier interaction. So in order to do a check, we must have first done a test. It's very difficult. I don't think you can do a check without having first done a test. And for me, checking is repeating an earlier interaction, looking at something that you've seen before, comparing that with a previous observation, looking and seeing if anything's changed, and then drawing a conclusion. So the checking side, now I've seen this done by people, I've seen this done by code, I've seen this done by unit tests, I've seen this done by automated UI tests, I've seen this done by testers in China and India which are following instructions off a piece of paper. But for me, the most important thing is it's the testing that unlocks the checking. Okay, so are we all on the same page now? Does everyone, so when I say I'm talking about a test, or I'm talking about testing, I'm talking about this side on the left and the stuff that sort of human beings do. And when I say checking, I'm talking about this side on the right, which is done by code, by scripts, okay? So like, I'm going to elaborate a bit more on the testing and the checking ideas. And I'm going to basically say that instead of calling it testing, I'm going to call it exploratory testing, okay? Now, testing for me is exploring, okay? It allows us to be creative. We get to look for new problems. We get to think about lots of different ideas. We get to make observations. Those observations, in turn, generate more questions. The focus generally tends to be on bug finding, but the joy with exploratory testing is you never know what you're going to find. So, in comparison, I'm going to call it scripted checking. Now, some people might call this test automation, but to me, going from the first slide, I don't consider this a test. I consider this a check. So I'm just going to call it scripted checking today. Test cases and test scripts, sometimes done by humans, sometimes done by automation. The key identifier for a check is something which is repeated. Generally, every single step is documented. You either get a pass or a fail result at the end. Focus tends to be on coverage. And somebody has to have imagined and done the test first for you to be able to come along and do the check. Okay, right. That's the boring bit out of the way. Okay, so to me, because obviously I worked in games for a long time, if testing isn't fun, then I think you might be doing it wrong. So I'm just going to jump into a really fun analogy now. Hopefully it'll keep you awake. I don't want to kill you with PowerPoint. I want you to like to imagine that building software is like mining. Okay? So just think about it for a second. So building software is like mining. Okay. In the mine, the ceiling of the mine could cave in, okay? And the floor of the mine could collapse. And either of these problems could occur at any time or at any point. We could have a disaster at any point in the mine, exactly the same as software. We could have a bug in any area of the software, at any point, at any time. Someone once said to me, how come making software is really hard? Like, you know, if you want to build a house, you draw up a plan, you get some bricks, you build a house, you can plot everything on a timeline. Why is making software so hard? And for me, making software would be the equivalent of building a house out of bricks where any one of those bricks could fail. Any one of those bricks could just suddenly stop being a brick and the whole thing could collapse. So we've got our mine and we've got these problems that we're trying to solve in the mine. We need to stop the ceiling from caving in and the floor of the mine collapsing. Okay, so in our imaginary mine, we've got devs, and I've made the devs into the miners. They're mining away at the coalface. As they're writing code, as they're churning stuff out, they're basically excavating new areas of the mine. And we've got the testers, which are the mine safety experts. Now, as you can see, they're all on the same team. They're all working together, but they've got different roles. Basically, as the testers, we've got to protect the devs from themselves, because we've basically got to protect everyone in the mine so it can grow and be successful. But the devs, they're going to write crazy code, and you know, we've got to sort of ensure everything is is tested. So, going back from the first slide with the testing and the checking, in this imaginary mind, we've got two activities which can be going on. We've got exploring and testing. Now, the mine safety experts would be basically walking around looking for signs of danger, like cracks in the floor and the ceiling. They would actually be looking with their own eyes. They wouldn't be relying on an earlier report. They'd be sort of getting in there and actually looking for problems, okay? And the scripted checking. Now, I've said that this is adding support pillars between the floor and the ceiling to prevent the mine from falling in. It's very, very important to remember that in order for the checking to be done, the testing must have been done first. So somebody has probably come along and they've checked that there isn't a crack here, and then it's a good place to actually put a pillar in. So that's going to lead on to my next slide, which is how would you identify the best places to construct support pillars? How would you identify the best places in your software to make these scripted checks? Now, I've seen a lot of testers which they've learned to program, they've learned to automate, they now have the ability to write code, they have the ability to drive a web browser, and they sit down and they go, yeah, I've got all the tools I need, I can automate all the things, and they sit down and then they draw a blank because they don't know what they should be automating. I've seen that. Has anyone else seen that or experienced that? As in, you've got the power to write these tests, but you're not really sure which tests you should be writing. Now, it's not a mystery. It's quite simple. The criteria for what to automate comes down to two things. It comes down to risk with a little bit of common sense. Okay, so in the context of this mine, thinking about the best places to put scripted checks in place, thinking about risk, first place, the entrance. These are places where it's going to be absolutely critical if there's a bug, critical if there's a failure. If the entrance of the mine collapses, nobody can get in, it can't function as a mine. This would be your equivalent of your login screen in the software that you're testing. Can a user log in? Okay? We've also got sites of previous disasters. These would be like precautionary scripted checks. These would be things like, well, we had a really, really bad bug last Thursday when the production thing went offline, so we're going to add a scripted check to make sure it doesn't happen again. Got hazardous terrain. This is stuff like back-end systems, places where it's difficult for people to take observations, so it's difficult for testers to see what's going on there. Adding scripted checks is a really good idea there. High traffic tunnels. These are things which impact on lots of people. So if, for example, you've got a section in your app and it's like the most popular section, everybody uses it, that's a good candidate for adding some scripted checks to make sure that it's okay. And lots of tunnels joining together, complex areas, good candidates for adding some checks there. And I've also got crumbling walls and fragile places. This is the stuff which always breaks, and you need to know straight away, has it broken again today? So, moving on, going back to the other side, the testing and the exploring, how are the testers and the mine safety experts in the mine going to find the problems while they're exploring? So, this is a bit harder than the scripted checks. There are no hard and fast rules about this, but I would say that they're going to generate ideas, okay? And these are going to be things like heuristics, they're going to have an idea that, I wonder what happens if I do this, and they're going to just try it, okay? They're going to be doing some exploring. They'll also be drawing from experience. You know, if they've worked in a mine before, they'll recognise common signs of danger in a mine, like, oh, that's a specific type of rock that always gives way. You know, drawing from experience. Knowledge. They'll follow rules, but they'll also try to break rules as well. You know, this is Oracle comparison. Yeah. So the oracles we mentioned before, the competitor's product, the expert user. They would basically be trying to find out what's expected, and they'd be constantly looking at the oracles to see, you know, is there a problem here? You know. We've also got playing with data, defaults, boundaries, extremes. You've probably heard of boundary testing. Hands up, anyone who's heard of boundary testing? Yeah, you're still awake. So we've got like various heuristics and stuff like this, but the testing side is all about generating ideas and applying ideas to the software, and normally for the very first time, making new observations as we go along. Oh yeah, words ending in eon. Interruption, duplication I've got on there. Things like navigation, selection, trying to think of the one, starvation, configuration is a good one. Go and change all the config settings to something nobody's expecting. You might find some bugs. Got heuristics on here as well. Just a couple. Goldilocks. Anyone know what Goldilocks is? Okay, it's just a heuristic is almost like a shortcut to problem solving. It's like a little cheat to generate some ideas. So Goldilocks is one I've heard before, which is too big, too small, and just right. So if you had like a text input box that accepted a number, you try to type in a number that's too small, a number that's too big, a number that's just right. CRUD, that's create, update, create, read, update, delete. So if you can create a new customer record, try create one, try read one, try change one, try delete one. Okay, and I've got out of order as well. Now, out of order is doing things in a different order to what the software might expect. Really straightforward. So like if you've got an online shopping cart, you might normally expect to add an item to the cart, add a voucher code and check out. Doing things out of order, you might decide to put in your voucher code first and then add an item and then check out. Or you might try to check out before you even put an item in or a voucher code in. But basically just mixing things up and trying to do things in different order. I've got opposite pairs, things like fast, slow, longest, shortest, sensible, reckless, mandatory and optional. There are loads of pairs like this. So you do something a certain way and then you try to do it the opposite way. And these are just a few of the ideas of how we can test in an exploratory way. So getting back to the mine, why would it be a bad idea to attempt to try support every square millimetre of the ceiling with support pillars? So this question is basically saying, why would it be a bad idea to try and automate every single possible test that we can do for the software that we're looking at? Why might that be a bad idea? Well, it's going to be time consuming if you try to automate everything. It's going to be expensive in terms of time and effort and also maintenance, Once you've got some of these support pillars don't come for free. You've got to place them strategically so that you're getting the most value out of them. It's just not possible. If you jam a mine full of support pillars, nobody can even get in there. It's not even a mine anymore. It just won't function as a mine, and it's just a bad idea. So like I was saying before, think about the risk and apply common sense. If anybody ever tells you we have to automate everything, just say no. Just say no. Okay, so next question. What would happen if you tried to make a human do the job of a support pillar and hold up the ceiling? Now, this is an interesting one because this comes back to the scripted check. You remember the first slide with the testing on the left and the checking on the right? And I said that I have seen sort of people working in China and India doing the checking side. Well, for me, when I worked in the games industry, we didn't have pillars. They were a luxury item. We didn't have scripted checks. We just had the exploring and the testing. And some of the things that happened were basically, we had a team that grew in size and we didn't have any checks. But for making people do the job of support pillar and holding the ceiling, this is very, very repetitive work. This is going to demoralize your test team. You're making people try and do the job of code, essentially. But you haven't got any of the advantages of using code. So whereas a piece of code will execute and run the same test the same way 10 times, you say run, it runs, you say run, it runs, it does it the same thing the same way. If you've got a human element, you've got an element of human error in there now, if you've got humans doing your scripted checks. Bob does it one way, Thread does it slightly different way. They both go the same test, they both get slightly different results. And also, it's very repetitive, and also it can cause your test team to lose morale as well, especially if they're very, very simple tasks. So, I just want to quickly summarise the exploratory testing, exploring the mind, looking for danger, because there are positives. I'm not going to read all of these out. I'll move out of the way in case you want to see. But there are positive aspects to exploratory testing. The main one for me is it's very, very fast to start. You don't need to install any specialist tools, you just get on and do it. It's very flexible. You haven't got a massive suite of tests that you need to constantly update and constantly look after. Yeah, quite fast feedback. But exploratory testing isn't everything because there's also negatives, you know. Some of the negatives on here, these are probably objections you might have heard in companies where they don't want to do exploratory testing. It's very labour intensive. No two testers will test in the same way, so you can't really reproduce results. The main one on here, the main sort of negative that I've seen is it's harder to record than scripted checks. Managers, basically, they want stats, they want metrics, they want KPIs, they want to know what percentage coverage they've got. And this is one of the main sort of weaknesses of exploratory testing, is that it can be very difficult to document what you've covered and what you've done. So, yeah. You also need to know about the software, you need to know about your oracles, you need to sort of have that kind of approach. So, the scripted checking as well, we've got some positives. Like I was saying before, 2 humans, if they're running a scripted check, might do it in slightly different ways. But if we're doing it with code, if we're using code to do the scripted check, then we've got reproducible results. And also, we've got all of the statistics that the management want, all of the project managers. With our scripted checks, we can write 100 of them, and we can say 100% of 100 tests pass. And they go, that's brilliant, let's release it tomorrow. And, you know, it's good for establishing that existing functionality hasn't changed. So, also got negatives for scripted checking. Yeah. You can't define all the possible scripted checks. There's going to be an infinite amount of tests that you can do, so you're always going to have gaps. And, you know, you need time to write the tests, you know, you can't change them, repetitive work for human, fixed ideas. I've also got on here pesticide paradox. Is this a term anyone's heard before? You've heard pesticide paradox? Okay. Pesticide paradox is a theory that the more you test the software, the more the software, the bugs will become immune to the tests that you do. So let's just say I have my 100 tests and I run them once. The first time they run, they might find some bugs. If I continue to run them 100 times the following week, there would probably be a lower chance that they'd find bugs because they're just checks. So the more you test the software in the same way, the more it becomes immune to those tests. So I hope that I've given you a good overview of scripted checking and exploratory testing. So I just wanted to put it out there, you know, which way. Well, first of all, let's just have a show of hands. Who thinks that they do exploratory testing in their day-to-day tasks? Got some people doing it, yeah, quite a lot. And who thinks that they do checking? Yeah? So it's about 50-50 really. We've got some people doing a bit of both. Which side of the coin is best? Right. Well, for me, it's best to be on the edge. It's best to balance between both sides. You've got to keep everything balanced, okay? Now, if you have no exploratory testing, basically what's going to happen is you're going to have few checks written, but you're going to have gaps. And what's going to happen is because nobody is actually using the software the way that an end user is using it, because there's this check or check that I can log in. But a user might log in and then do something else, and then do this, and then do that, and they might go on this really long journey through the software. I bet you're not going to have a scripted check which will go on like a really long user journey for like a 3-hour session and hit a memory leak and crash. Okay, so you're going to find that if you only do the scripted checking, you're still going to get, no matter how many scripted checks you do, you're still going to get bugs on production because you're not using it the same way as your users. If you don't do exploratory testing, so with the exploratory testing, sorry, I've just lost my train of thought. What was I? So yeah, if you do scripted checking only, you still get bugs on production because you're not using the software in the same way as your users. Okay. If you do exploratory testing only, right? Now this is what I experienced in the games industry, only doing exploratory testing, and this is where you can't cover enough ground quick enough for the release. So you get a new build on a Tuesday, it wants to go out on a Wednesday, and you've suddenly we've got to do a massive regression test. how are we going to do this? All hands on deck, everybody's working overtime, everybody's trying to get through and check everything. And just to make sure nothing has changed and everything is still the same. And it always feels like you haven't got enough time, you haven't got enough people. More people get hired, but even then regression basically becomes this massive nightmare task because you haven't got the certainty of the scripted checks, you haven't got the fast feedback. Okay, so some symptoms if you've got unbalanced checking. Probably mentioned these already. If you haven't got enough scripted checking, enough scripted tests, enough support pillars, you're never going to have enough time to test sufficiently. Your test team will feel understaffed. And like I was saying before, you're not using it the same way as you'd use it, you're going to get simple bugs slipping through, and it's going to be a regression test nightmare. Okay, so not enough exploratory testing. A lot of time spent writing tests, even more time maintaining existing tests, demoralised test team, end users still finding really bad bugs. So we've got to have a bit of both. There's always got to be a bit of balance. So just to summarise, only doing one of exploratory testing or scripted checking is going to land you in hot water. You're going to have some problems. It's best to try and keep things balanced, and also try to keep things balanced from the start of your project. You know, if you're not doing exploratory testing, set aside a little bit of time for it. If you haven't got any unit tests, it doesn't matter. Just start trying to write them. You don't have to catch up straight away, but just try and drag the balance back. So if you're only doing one, try to do a little bit of the other. You might not catch up, but you can start making improvements there. Humans are good explorers, but not just a good choice for doing repetitive scripted checks. And this is why, you know, these workers in China and India and places where they're only executing test scripts, they're not seen as especially valuable by people which are working sort of in sort of more technical jobs. They're seen as disposable, they're seen as unskilled work. And these jobs that doing the scripted checking is normally outsourced to the lowest bidder. So, you know, try and get your scripted checks done by code. If you can get them done by code, what this will do is it will free up the time for your human testers to actually do the fun, interesting, exploratory work themselves. And then they'll still have the support of the scripted checks for when they come to do large regression tests. Exploring is a good way to identify areas where scripted checks can be added. So you might be doing an exploratory test session and you might find something interesting and think, hey, we need a test, we need a check for that. And you know, quite often now on teams, it's you remember the slide with all of the miners and the devs and the testers? It's a team activity. So, you know, as a tester, you might think, oh, we need a scripted check here, but you might not be sure how to write it. So a developer will work together with a developer and get them done together. Don't try and add scripted checks for absolutely everything. Use common sense and consider risk. Talking before, is it agile? It's don't boil the ocean. Yeah, you know, automate all the things is not a good strategy. And also keep in mind that these scripted checks require maintenance. Right, so coming to the end of my talk now, I've just got a few acknowledgements. This talk was inspired by a discussion I had with a man called Robert Page on Testers.io. Testers.io is a Slack chat. The last time that I looked, there was 2,337 testers signed up to this chat room. All very friendly, all very helpful. If you want any advice about software testing, I would highly recommend get on Slack and just start a conversation on there. Because you know it's so wonderful that we have such a vibrant community full of people that want to help. So yeah, credit to Robert for helping me with my ideas on this. Also, all of my images are Creative Commons as well. So thank you for listening. I hope I haven't put you to sleep.
Yeah.